Hi, my name is Aiden LiVigni, and my project was the effects of material density on flag stability. So to give some context, and ever since its inception into the flag industry, nylon has sort of dominated and been the best and top choice for flag manufacturers, and for good reason. Using its strong synthetic fibers, it resists tears and rips. It doesn't grow or shrink over time, and for a product that is always outdoors, subject to the elements, it is perfect. So as a little introduction, this experiment was to determine the objectively best material to utilize for a flag, because while nylon has been seen as the #1 flag material, it's not necessarily known why. And if we can pinpoint the reason why or the variable why, we may be able to find a better material. Flag manufacturers pay for their logo to be seen, and if a material is better at keeping their logo stable and better at keeping it seen, then it was more cost effective for their brand and even just for the everyday consumer. So the hypothesis going into this experiment was if a less dense material is used, then the flag will become more stable. In our context, more stable means that the end of the flag changes position less, the end of the flag not connected to the pole, of course. Justification for this was that in a system dealing with wind, the more resistance exhibited by the object, the more chaos introduced into the system, and therefore the more movement will occur. An example this was tied back to was that studies done with a flag with and without tatters showed that the tatters caused a lot more chaos. And this was because the wind would feel more resistance from it because it could not only pass by the flag, but through the flag. And this chaos caused there to be a lot more variability. So the following image will just show some of the testing materials and methods. So this is the wind tunnel at Wachusett. It's from Alden Labs. This was the only place that any of the flags were tested. You can see a flag right inside right there. So the preliminary wind speed testing, this was when an anemometer was used around the flag at different spots that were candidates for where the flags would be placed. And when a spot was finally chosen, the speeds were taken, multiple times. The machine was stopped and started to get an average, and it turned out to be about 9.8 miles an hour. So feasible for that wind to be existing outside. So it worked out. Flagpole placement, as you can see on the far left, is the wooden pole. This was the pole that the flags were hot glued to, as you can see on the right with the silk. And in the middle, that's where the flagpole was placed within the wind tunnel. The graph on the back was just to measure, as the graphing squares are a uniform length, and so easy to measure once you know the length of them. The glass covering was just so that there would be no drag and no opening required, and that the video could take a consistent angle and an angle with the graph right behind to see how much the flag is moving. So the following slides are going to show the data collected and the subsequent graphs from that data. So on top, you can see the raw numbers that were collected. And right below that, you can see those numbers turned into a graph. And the graph is a little bit confusing, so I'm going to just break it down from left to right. Nylon is blue, cotton is red, denim is yellow, and silk is green. We can see an obvious trend with there being a rise, a fall, then a rise, and then another fall with all of the materials. What's interesting is silk, the least dense, starts a lot higher on the left, and this is because it started moving a lot faster. Cotton had the most chaotic movement, going from 10 to a high of almost 25 centimeters. Denim stayed fairly consistent aside from the very beginning. Like I said, as a denser material, it'll be harder to move, but overall, the data is consistent with what was observed, and it looks like all the flags followed a similar pattern of movement. A t-test was used to discover if the data was or was not significant. As you can see, it was kind of hard to tell. The green squares show data that was significant. The red showed that data which wasn't. But with the help of the candlestick graphs, it's a lot more obvious. You can see that the nylon, as expected, was very consistent, and the others not so much. Although denim is in second place, and as you'll see in the conclusion, density is likely not the variable which affects flag stability the most. This is because materials on varying ends of the spectrum performed similarly. The examples being nylon and denim performing the closest out of all the different materials, at the highest. If this experiment were to be continued, more accurate testing would be needed. Definitely a more accurate way to measure. As with the graph, it allows for a lot of human error and a lot of video corruption. Like if the video was ever blurry, the measuring became very difficult, and humans make mistakes. So a human measuring and counting these squares could obviously screw up. The variables that would be tested in the future would probably be ones more in tune with tearing and ripping, as these are things that nylon exhibits. And so if another material were to exhibit these traits, it's possible that it would have the same wind effects as nylon. My name is Aiden LiVigni. That is my project, and thank you so much for listening.